This is AP Calculus Lesson 2-5. We're talking about exponential and logarithmic chain rules. And that is disconnected. Let me disconnect that so that doesn't pop up anymore. So yeah, this is where we are in our unit guide, exponential and logarithmic chain rules. We're almost done with basic derivatives, getting closer and closer every day. And I just abbreviated in my notes, E and natural log chain rules. So a bit of review before we actually talk about those chain rules. What do I mean? What do I have when I'm in power house versus exponential house or E house? So I just want to do a bunch of examples here. You guys can add your own here if you want. So 4x squared, that is power house. Other things that you might see, something like 3 times the quantity of, we'll do just like x plus 2 to the power of -4. That's still power house, even though it's a negative up here. You could have like a fraction too. You could have like, I don't know, -1/2 times the quantity of 2x to the power of 1/3. That's still power house, just the power is 1/3. So generally, if you're in power house, and I'll do this one in red because of the general rule, you'll have like some number outside times something right there to some number. And just labeling everything here to review. This is our base. This is our coefficient. And this is just some constant. If you don't like the word constant, just think of this as the octothorpe, also known as a hashtag, also known as the representation for number, but it is formally called an octothorpe. So we know what power house looks like. It looks like one of those forms. Let's compare that to our E house, our exponential form. So if I have something like 3 times 2 to the power of x, that's definitely going to be an exponential. It's not necessarily E house, but definitely is an exponential. You can also have -4 times the quantity, or -4 times 5 to the power of 2x minus 1.
So it's when the variable isn't with the whole equation involved.
Yeah, exactly. So you're trying to get up here. I can come to that right now since we want to talk about it. Yeah, so this one, the variable was down here in what we called the base. Up here, the variable, as you can already see, it's not in the base. It's up here in the, what do we call that number? In the exponent, yeah. Ran out of room there, but it's the exponent. And then in order to be an E house, you have to have something that looks like this. So we'll just do 1/2 times e to the power of something in the exponent where we have a variable. And let's just do the general rule here in red. So you have some number, some coefficient out in the front, and it's multiplied by e to some power, where that some power has our exponent. And when you deal with exponentials, this number, technically, yes, you can call it a coefficient, but in terms of the graph, it's usually the height of the start amount. So this is the height, or you can just say this, the start amount. There's our review from, where do we do exponentials? In Algebra 2. And our E, that's usually called our, I mean, it is our base, but in terms of talking about exponentials, it's called the multiplier. How fast are you multiplying by? If this is a big number, it's even steeper of a graph. If it's a fraction, then it is not. It's going down, because each time you're fractioning your number. Anyway, let's move on to the part of the lesson that I care most about today, the actual rules. So our first rule is the chain rule for exponents. So let's do this in red. I'm just going to give you the rule right off the bat. Star this. This is the important thing to take away. If I'm taking the derivative with respect to x, d dx, of some coefficient, I'm going to make this bigger, some coefficient, and we're in E house, e to the power of something, that turns into the same coefficient times e to something. What? Mr. Sindel, that's the same thing. Yeah, it's the easiest house to remember. So
derivative, when you find a derivative with respect to x, you just do nothing.
Yeah, that's doubter is the same thing. So again, this thing right here is doubter. Let me do this in a different color. This is not as important. This whole thing that we just found is doubter. Doubter is the same, all caps. It's the same. It's easy to remember. However, you might have a dinner. you might need to multiply this by dinner. So the dinner is where you might get tripped up. So don't forget dinner on this one. So you might, I'll do this over here in a different color. You might have something times dinner. So don't forget dinner. Never forget dinner. Otherwise you're going to go to bed hungry. I'm realizing it's kind of hard to see. Arrow, do you want to turn off the lights for us, please?
Are there times when you won't use dinner?
Yes. And someone else answered that question. When are times?
There's always a dinner, but what if it's just one?
That's it, yeah. So your inner could be x. So for example, I'm going to do this on the side margin. If I had e to the power of x, my inner is x, so my dinner would be
1.
exactly. So you'll always have dinner. Sometimes it'll be 1, as Ben said. Good question. I like that question. Anything else I want to say here? No. Just make sure that you're always multiplying by dinner. Let's do some examples. So example 1. Let's find the derivative with respect to x, d dx, of 2e to the power of 3x. And let's set it up, I mean, you could probably already solve this by yourselves, but let's set it up like this. That way we just get into the habit of knowing, oh yeah, it's always 2 things, maybe 3 things, depending on what that inner was. All right, so this first thing, what is it? What is the first thing that we always try to find? Oh, you're about to solve it. So I'm going to back you up. Like, what is the thing that we're trying to solve without actually solving it? It's called something, kind of like doubter. It is doubter. Sorry. Doubter is always first. And then the second one is dinner. Let's label those. Always find doubter, always find dinner. You might have a dinner inner.
Do you think it would be, like, do you think it's important that it's doubter first and then dinner?
Yes. I mean, in math, it doesn't matter because it's the is it commutative? I think it's a commutative property of multiplication. It might be the associative. I think associative is where you can just change the parentheses. But yeah, the commutative property of multiplication means I can switch these two and it doesn't matter the order. But for the sake of doing it the same way over and over on the AP test, just keep it in this form and you'll be fine. You'll just get into the habit always doing doubter times dinner.
Some kind of disaster happened.
I know.
There's definitely an ambulance that time, so.
Yeah, I think it was an ambulance before too.
Yeah.
Yeah, okay, now you guys help me out. Find doubter in dinner. What is doubter?
2 times e to the power of 3x.
E to the power of 3x. Beautiful. And someone new, find dinner.
3.
3. Done. We knew what the outer and inner were. I could write that down here, but I think you guys are pretty experienced at finding outer and inner. Let's try one more example before we move on to the log chain rule. So example 2. I want to find the derivative with respect to x, this d dx of, I'm going to put parentheses around this because I'm going to have a negative, e to the power of x squared. It's like a giant trio of exponents. All right, same thing as before. I want to set this up properly. I'm finding what times what?
Doubter times dinner.
Downer times dinner. Doubter times dinner. Over and over again. All right, either Ben or Arrow do doubter.
Negative e x squared.
Negative e to the power of x squared. Perfect. Ben, do dinner.
2x.
2x. Done. I mean, you want to simplify this as, of course, in the final answer, and it would be like negative 2x e to the power of x squared. I think you guys know how to simplify that. It's pretty straightforward. And we are almost done. Slide 3. Last slide. Log rule. So, giant red star. I'm going to give you the rule right off the bat. Here we go. The rule is, if I take the derivative with respect to x, this d dx of a constant multiplied by the log house, so natural log of our inner. There's our inner. Our inner we usually call u. And this one is pretty fun. This one turns into a over u. It would be cool if it was the same thing. Then you could just memorize 1 and be done. But sadly, it's not. It's kind of weird. It's a over u. So a over the inner. A over some quantity. Turns into a fraction. By the way, I'm going to pause right here. We should always be thinking of going backwards too, because the second half of calculus is integral math. Integral math is going backwards. It's saying, I give you a over u, and you know if I take the integral of it going backwards, I come back to the natural log. So with all of these, if you think about that in the back of your mind, then it'll just set you up to do really well on integral calculus. Right now we're just doing differential calculus, taking the derivatives of things. Differential is the adjective for taking derivatives. All right, so with our differential calculus, let's do 2 examples. Ejemplo número 1. Or I guess it's número 3, I guess. It's number 1 if you're talking about log rule. Let's do the derivative with respect to x. This is d dx of 2 times natural log of x cubed. I put parentheses around this because I don't know exactly what I'm taking natural log of. I might have some other constants over here, so just be careful. All right, we're going to be multiplying 2 things. What 2 things do we multiply?
Daughter times dinner.
Daughter times dinner. Yep. Daughter times, I should have it times here, dinner. If I was pronouncing this correctly, it would be dinner, I guess.
Should it just be 2 over x to the 3rd?
Ah, so, well, yeah, let's do that. So you're saying daughter right now is what?
Well,
2 times ln of x.
Be careful. So that's outer.
Oh wait, no, I meant 2 over x to the 3rd. But no, x to the negative 3rd. Okay?
Yeah, I don't know what to do. Good ideas, everyone. Arrow, you want to take a stab at it? Some of you have it correct. I'm not disregarding you guys.
Is that a over u just the derivative of the outer?
Yeah, that's daughter. This thing is, we can label that too. That is just our daughter, just like before.
And then the u is.
And then you have to take the derivative of u, which is the
Since
dinner.
the u is on the bottom of a fraction and x to the 3rd has an exponent, would it turn to a negative?
It doesn't turn into a negative unless you are applying some additional rule. So it stays positive, I think is the answer.
So then it would just be 2 over x to the 3rd.
It is 2 over x to the 3rd. That is daughter. And then Ben or Arrow, since Rochelle just did this one, find dinner.
3x squared.
You both got it. Nice. There it is. And then you would want to simplify this, of course. And simplifying this, I just want to do this one out because maybe it is a little bit confusing. This is 3x squared over 1, right? Which means 3x squared times 2 is 6x squared over x to the cube. And that simplifies to what? Anyone?
6 over x.
6 over x. That's the answer that you'll be giving in my class. And because this type of problem is more typical of a multiple choice question, multiple choice questions have the tendency to simplify for you, so you do have to simplify. On free response, though, you probably don't want to ever simplify. You'll lose points.
It's just a waste of time.
And it's a waste of time, yeah. I mean, it's bad in both ways.
And you can make an error.
Yeah, so many ways to lose points. Ejemplo número 4, our last example. Our derivative with respect to x for this one, and I'll wait because you're probably still writing down an example. Our derivative with respect to x, our d dx is, we're going to take the derivative of negative, do parentheses here so you know what I'm taking. I'm going to do a square bracket actually because I'm going to put parentheses around the natural log.
Or you could just use nested parentheses. That's what I do.
Okay, nested parentheses. They're a little bit harder to read, but it works. Natural log of the quantity 5x squared minus 3 end quantity end square bracket.
I use nested parentheses when I'm writing even.
Okay.
Various times I've had a parentheses within a parentheses. Like explaining something that was already an explanation of something else.
Yeah, usually what I do for my parentheses is I go like this and then I start repeating them. So I start with normal parentheses, then square brackets, then curly braces, and then I go back to normal parentheses. Is my hierarchy. You can do it my way, you can do it any way you want. Just normal, I think by nested parentheses you just mean like this, right, Ben?
Yeah.
Yeah, so those are a little bit harder because they don't stand out as easily, but programming does the same thing, so it's fine. Let's solve this guy. What 2 things are we multiplying together over and over and over again?
Daughter times dinner.
Doubter times dinner. I can write this neater, Mr. Sindel. There we go. All right. Someone find me a doubter. The other person's going to find me a dinner. I don't care who it is.
Negative 1 over parentheses 5x squared minus 3.
All right. And then I need a new person. Find me my dinner.
It's 10x.
10x. You agree, Ben?
Yep.
I agree as well. And you'd simplify this, obviously, just by putting the 10x in the numerator, but you couldn't simplify it anymore because there's nothing that you can get a common factor for the numerator and denominator. That concludes today's notes. Are there any questions before we write summaries? Oh, I do have a question. What were the questions? Or what were the what were the questions that we should be writing up here? What was this chain rule called?
Log rule.
What is the log chain rule? And that's right, for 100 points. Or is it $100? What do they say on Jeopardy?
I don't watch Jeopardy.
I should watch more too. Okay, what is this one? What rule was this?
Natural log.
No, it's
Careful.
something
Yeah.
Exponential.
Yeah, there it is. What is the exponential chain rule? Question mark. All right, perfect. We have our questions. Go ahead and do summaries.
What about the beginning?
The beginning actually had a proper title.
I forgot to make that into a question. What is the difference between powers and exponentials? Would have been the question, but Mr. Sindel is so used to doing just titles. It makes sense to me. I don't know. Yep, summaries, and we are done.